We've already covered chapter 4. Okay?
Okay.
Bad news is you got another test. I broke up Unit 2 test into 2 sections. The first unit you're taking right now, the first part you're taking right now. Now we're going over chapter 4. But the reason I do that is because some of you have had completing the square, but some of you have not. And that's why I hammered completing the square, completing the square, completing the square. And then afterwards, we went into doing an equation. Now, you remember those family of graphs or parent graphs I gave you and going over the vertical and horizontal shifts? Well, that's what we're doing in chapter 4. So you kind of can lay back and not worry too much because we've already covered it. Okay? Good morning. So, 4.1, transformations and graphs and symmetry. Transformation of graphs and symmetry. So, you're really not going to have to put too much effort in this because we've already covered it. You're welcome. All right. I'm not going to go over this because that's just a lot of writing and you don't need to go over it. All right, now, for instance, go ahead and graph these 2 graphs and see if you know what's going to go on. You should know what's going to go on by looking at it, but go ahead and graph them on one piece of graph paper. I watched Thor last night. It was good.
Oh yeah, that was pretty good. I saw that this weekend too.
On my Fire Stick. The only problem is the last bit of it was in Spanish. So
Was it?
yeah. So I got to watch. I got to watch pretty much 2/3 of the movie, and then the last third when they were fighting the Hela or whatever her name is on the bridge. Was in Spanish. And the fire.
You tell me your Spanish.
Fire god. When the fire god broke through the palace, that was in Spanish. So, but it was free. It was a good movie.
It was pretty good.
I like Thor. They don't have those 2 people in there that shouldn't be Avengers. What's their names? The two
that don't do anything.
Yeah, all they did. I mean, a bullet between the eyes and they'd be dead. What's their names?
I can't think of their.
What's the 2 Avengers that don't have any powers?
One with the bow and arrow.
Yeah, Mr. Bow and Arrow guy.
Hawkeye.
Yeah, he's stupid. And the other girl.
Black Widow.
Yeah.
She knows a lot.
I don't even understand why they're in it.
They haven't died yet, and they have a purpose.
Yeah, their purpose is what?
Good question.
Things.
I ask my purpose a lot too.
Well, that we understand that's why your purpose is. We understand that. Go through enough group sessions. When you go through enough group sessions, you'll find out.
Well,
You gotta make
it
that
costs a lot of
break
money to
through.
go to these sessions. I need to get the results now.
You got to pay for healing, man. I'm sorry.
I know.
All right. So when you graph these 2, what are you gonna find out?
I'm going to see a vertical shift.
The 2 is not connected to the x squared. It's not within the square, so that means it's a vertical shift of 2 up. And that's what you're going to do. Now, most of you should be saying to yourself, oh, I know that. You should be, because that's what we did in the last unit. So you should be able to go through that and not have any problems. You're welcome. There you go. And that's what it should look like. So make sure you're able to determine what the vertical and horizontal shifts are. Now, if you have to do completing the square to get to that point, that's fine. But that's what you're doing. And you don't have to go through this right here. You just have to do is the graph the same? Is the red graph and the blue graph, are they the same parabola? Yes or no?
Yes.
Yes, because the 1 is in front of the x squared. So they are the same parabola. If you take the red one and pull it over the blue one, or the blue one and put it over the red one, it's the exact same thing. The only thing is you have a vertical shift, and that positive 2 tells you that it's a vertical shift. Capiche?
Yes, sir.
And that would be a negative 2 would be a vertical shift 2 down. Now again, all of this should be kind of like review. So your homework should be very easy tonight, unless you screw it up. So positive K means a vertical shift up, negative K means a vertical shift down. Now, what if the 2 is attached to the X? Then it's a what? Shift, Hubert. That's right, class. It's a horizontal shift, meaning the opposite. So a positive 2 would mean 2 to the what?
To the right.
Opposite.
To the left.
Oh, to the left.
Yeah. So there's that. Again, we've covered this. So that would be 2 to the right. So a horizontal shift is opposite. If it's negative h, it'd be 2 to the right. I mean h to the right. If it's positive, it'd be h to the left. So what's the vertex of this function right here? Y'all have to look at the screen, to get it. F of x is equal to x plus 2, quantity squared plus 1. What's the vertex?
2 to the left.
And
1 up.
1 up. Bless you.
Thank you.
Okay? 2 to the left and 1 up. All right, just for giggles, graph this function, just sketch it, and answer A and B. Now what they want you to do, they want you to sketch it and not use the calculator, so you should be able to do that. Now, when you graph a function like this, the main thing you want to do is not get stressed out over it. It's not that big of a deal. Okay? Draw a graph. You know that this right here says it's opening which way?
Down.
It's opening down. You know that this is a horizontal shift of 55 to the right, and this is a vertical shift of 4,500. So that is 55, 10, 30, 40, 50, 60, 55, and then 4,500 is way the heck up here. All right. Now, what is the y-intercept? Well, in order to get the y-intercept, you're going to have to actually expand this out and get the y-intercept, and you can do that. That's not a problem. P of x is equal to, just put that negative there, and this is shortcut number 2, so that's going to be x squared minus 2 times 55 is 110x minus, or plus, that 55 squared. I don't know what 55 squared is, but somebody do it for me. What's 55 squared?
A really good number.
3025.
I'm sorry, 3025?
Yep.
Yeah.
3025 plus 4,500. So that's going to be P of x is equal to negative x squared plus 110x minus 3025 plus 4,500. And somebody take 3025 and add 4,500 to it.
7525.
Okay. No. Negative 3025 plus 4,500.
1475.
1475. So there is your y-intercept. So 1475, that's 4,500. 45, 3,000, 2,000, 1,500. So somewhere around in there. And your x-intercepts, you could solve this for x. So negative x minus 55 quantity squared minus, so bring that over here, minus 4,500 divide by negative 1, x minus 55 quantity squared is equal to 4,500. Take the square root of both sides. Let's see, 49 is 7. So 7, well, somebody take the square root of 4,500. What do you get? Just give me a decimal.
$67.08.
67.1. And then x is equal to positive or negative 67.1 plus 55. And what's 67 plus 55? 123?
22.
I'm sorry, what?
122.
22.
122.1. And negative 67 plus 55. What is that? Negative 12.1. So there's your two x-intercepts. So just by this piece right here, you're not only able to find the vertex, but now that you know what's going on with this thing, you know how to find the x-intercepts, and you know how to expand it to find the what? The y-intercept. Now, if you don't put those three things together, you've missed the boat. You've basically missed it. That's what you're supposed to be able to do whenever you're given a quadratic. You're not supposed to just type it into the calculator and say, okay, that's what it is. You're supposed to be able to function with it. You're supposed to be able to manipulate it. You're supposed to be able to change it. All right? That's the whole point of doing mathematics. Is not to put in a calculator. It's to manipulate and to not to be able to take something apart and put it back together again. And you're going into business and marketing, you're going to be doing that the rest of your life. Okay? So, now we got 12.1, negative 12.1 is over here, and 122 is somewhere over here. So there is your function. And you should be able to do that. Now, I have no idea what it's asking, but let's go back to the question and see what it's asking. If I could work my mouse, keeps jumping over to the other screen. Use the graph of y is equal to negative x squared and the appropriate transformation to set the window and graph the profit function. We just did that. Okay? How many elliptical machines must be produced and sold to yield the maximum monthly profit? Where's the maximum? Maximum is always going to be your what?
Vertex.
Vertex. So there you go. There's your answer. Okay? Question. And they're going to draw it, probably. Let me see. Let me put this up on the jigger and get rid of this. Oh. There we go. Okay, here's another one. The projected percent of the U.S. adult population with diabetes, diagnosed and undiagnosed, for 2010 through 2050 can be modeled by the power function blah, 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 with x equal to the number of years after 2000. Highlight that. Find the power function that models this projection with equal to the number of years after 2010. Well, we know this is a power function, so it's going to be looking like a swoop. It's going to be in the first quadrant. Well, you could put it in the second quadrant. And basically use your calculator on this. Okay? Projected percent of, let me make sure now, the U.S. population with diabetes diagnosed 2010 to 2050 can be modeled by the power function, blah, 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 with x equal to the number of years after 2000. So that's 10, 20, 30, 40, 50. Okay? Find the power function that models this projection with x equal to the number of years after 2010. There would be a horizontal shift, so you'd have to say x minus 10. That's what they're trying to get to. X plus 10, sorry. I don't like this question. It's kind of redundant. Define the power model that will give you the percent where x is the number of years after 2010 rather than the number of years 2000. We'll rewrite the equation, blah, 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 replace x in the number, so 2010 be 2020, 2030, 20 be 2030, where x is the number of years after 2010. Okay, so x is, so you can plug in 10 plus 10, that'd be 20 years, 30 years, and 40 years. Don't like that question. Original model, 10 years, 15%, and you do that. This is a calculator question. There it is. So, is there any difference? This is, you remember the question we had a couple of sections back, and I said you can't use 2000, you have to use the years after 2000. Well, this plays into that type of question. All right? You see where they do years after 2000 and then years after 2010? That's where the plus 10 comes in. And that means you've got a vertical shift. Let's see. You've got a horizontal shift of 10 to the left. And that's why everything moved 10 to the left. But this is not a question I would put on a test. I would ask it a totally different way than the way it's written. Okay? Don't like that question. Compare the graphs of y is equal to kx squared for k is equal to 1, 3, and 1/3. Well, what happens when k is equal to 1? What kind of graph is it? When a is equal to 1, whenever you have a 1 in front of your function, what kind is it? The basic what? Basic model, Hubert. It's the basic model. What about if you put a 3? 3 is greater than 1. What does it do to it? What does it do to the basic model if you put a 3 there?
Smaller.
Compresses it.
Compresses along which axis?
Y-axis.
X-axis.
X-axis.
What does it do on the y-axis?
Stretch it.
Stretches along the y-axis. All right. What about the 1/3? That's between 0 and 1. So that's gonna stretch along the x-axis and what along the y-axis? Compress. Okay. What is the matter with y'all this morning? Is it just a bad day or what? Okay. Well, I'll just sit here.
Be like savings time.
He said, I'll just sit here too.
I'm in a great mood.
Well, some of y'all look like y'all are weaned on a pickle. Y'all know
I
what
don't even
weaned
know
on a
what that.
pickle means?
I don't even know what that means.
Okay, well, weaned on a pickle looks like you're sucking sour juice. Okay? Put a smile on your face. You're alive, okay? Good gosh.
Tell him, Hubert.
Some of y'all look like y'all weaned on a lemon. How about that? You know what weaned on a lemon is?
I can't say no that one.
Go
either.
suck on a lemon and see what your face looks like.
What if we like lemons?
Then you're stupid. All right. So, you know what that does. There's your basic model. Now, what happens when you put a 3 in front of it? It's going to make it what? Narrower. And then what happens when you put a fraction between 0 and 1 in front of it?
Water.
Makes it wider. Now, all of you should have learned this back when I taught y'all all this stuff, back in chapter 3. Okay? Now, that's what that's saying right there. So go back to your notes. Suppose in a certain city, the cost fee of obtaining drinking water that's not lead poisoned, that contains P impurities, P% impurities, whatever, by volume, is given by blah, 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 blah. Well, the first thing you want to do is graph that. Okay, that's the first thing you want to do. Determine the domain of this function and graph the function without concern for the context of the problem. So just graph it. Take your calculators out and graph it. Even those that are weaned on a pickle. Get your calculators out too and graph it. I've told y'all since the first day, Mountain Dew, coffee, and Code Red.
Code Red. What's that?
You're going to get fired. I see y'all right now. I don't want to come in at 8 o'clock. I'm going to come in at 9 o'clock. You're fired.
No, I'm out.
So 120,000 divided by P, you just say Y is equal to 120 divided by X minus 1,200. So this looks like a linear function. How do you know it looks like a linear function? Well,
Because there's no squared.
there's no squared, but it could be 1 over X, which could be the half a volcano. Remember the 1 over X? Look at your parent graphs. Parent graphs. What are you talking about, Hubert? Well, you know that section I told you to draw your into 8 sections, and I gave you 8 graphs. Well, this one is looks like f of x is equal to 1 over x, and 1 over x looks like half a volcano. Of course, you're business majors, so which quadrant do you focus on?
Second.
The first. That's why you're not going to be successful as a business major. Okay? Why you focus on the first?
It's positive.
Because all this is positive, therefore what? You're dealing with what?
Profit.
Profit. So, that's what we're going to be dealing with. Now, the domain for this function, somebody tell me what you think the domain What was the function again? Oh, wait a minute. Let me move this over. C is equal to 120,000 divided by P minus 1,200. I'm going to rewrite that as Y is equal to 120,000 divided by X minus 1,200. All right, what is the domain for this function? All real numbers except X cannot equal what?
120,000.
It's a
Zero.
fraction. What can you not have in a fraction?
0.
0 in the denominator. So your domain is all real numbers except X cannot equal 0. So the range, look at your graph. Well, you got to graph this. What is the vertical shift? Negative 1,200. So that sucker's going to be way down here somewhere. All right? And that's what they're going to show you. So let's take our handy dandy graph, or our handy dandy calculator. Oops. And as soon as I can find my calculator. And let's do Y is equal to parentheses 120,000 divided by X minus 1,200. And graph. Now you're not going to see it because minus 1,200 is way the heck down there. So zoom. I would probably do either zoom standard or zoom fit. Let's do zoom fit and see if we can find it. Golly, look at there. There it is.
Magic.
All right. It's a miracle. Now, you know that this is around 1,200, okay? So I'm going to put 1,200 right here. Negative 1,200, because that is the new vertex right there. Negative 1,200. So that's why they have it set right there, but that's not a big deal. But, again, you're focusing on the first quadrant because it is the profit quadrant. Now, I don't know what the question's asking, but we'll go back to it and see. Determine the domain of this function. We've done that. Use knowledge of the context of problem to graph the function in a window that applies to the application. So if you wanted to, you'd go to Window, and what is the min on your y-axis that you would use? I'm pointing at it for those that are paying attention.
Negative 1,200.
Negative 1,200. So go to Window, and X max, you really don't care about the X max. You can make it 100, negative 100. But the Y min needs to be around negative 1,200. And you can make the top, oops, I messed it up. Window, go to, okay, negative 1,200. Okay. Window, exit, window. Oh, you got to hit the negative button, not the subtraction button. Negative 1,200. I'm going to go 1,500. And make the top 1,000. See what that'll give you. And that doesn't help at all. That's why I zoom fit 0. That's the best way to use it. And then of course you can use trace all you want to on that. Hit the trace button, and X is equal to 0. You can follow it all the way down as, like, see, it just keeps on going. All right. What is the cost of obtaining drinking water that contains 5% impurities? Well, 5 is going to be 0.05. So take your handy dandy sheet of paper. Y is equal to 120,000 divided by 0.05 minus 1,200. All right, somebody tell me what 120,000 divided by 0.05 is.
$2,400,000.
2,400,000, and then minus 1,200.
$2,398,800.
So that's how many households or whatever. Okay, what is the cost of obtaining drinking water that contains 5% impurities? Well, there you go. All right. And it keeps going. Here is the function. There's the function right there. And I showed you how to do that, so that's not a big deal. There's that. Okay, they're not using 0.05. They're just plugging in 5. My bad. Usually in formulas, when they give you 5%, you're supposed to change it to 0.05. But in this case, I guess they're saying that P is a percentage, so you just put 5. My bad. You're just going to come off with a little bit different zeros is all. Symmetry, we've already talked about symmetry. Line of symmetry, we've talked about that. Let's see what this one says. Okay, this one is 2x squared over x squared. This is going to be symmetrical around the y-axis. How do you know that? Well, if you plug in negative x and you get the same thing, then it's going to be symmetrical around the y-axis. You need to write that down. If you plug in negative x, or f of negative x, if you plug that in and you get p of x, then that means it's odd or symmetrical around the y-axis. Okay? If you plug in p of negative x and you get negative p of x, then that is around the x-axis. I can't spell today. There you go. So in this case, you take y is equal to 2, there's the test right there. Y is equal, now I don't forget that. I despise doing this class like this. Hold on. It only takes 3 semesters to install a smartboard at this school. 2x squared over x squared plus 1. 2x squared over x squared plus 1. Okay, so I'm going to plug in 2 times negative x squared over negative x squared plus 1. Now what is negative x squared? What is negative x raised to the second power? X squared. So that would be 2x squared over x squared plus 1. You get the same thing you started with. So therefore, it's symmetrical around the y-axis. Now, if you tried to do it the other way, if you tried to plug in p of negative x, you get this. But what if you put a negative in front of this? Would you get the same thing as this? No. So therefore, you have to try the y-axis. So these are the 2 tests that you try when you're trying to find if they are symmetrical or not. And it's either going to be symmetric around the x-axis or it's going to be symmetric around the y-axis. Is this very detrimental to you being able to pass this class? No. Okay? I'm much more worried about you being able to interpret a function, be able to dissect that function, and be able to tell me everything about that function. That's what I test you on. Okay? That's just part of it, and it's not that detrimental. Okay? And there is the symmetry around the y-axis. See? Question?
No.
Okay, here's one. X cubed minus 3x. X cubed minus 3x. Y is equal to x cubed minus 3x. So first of all, I'm going to plug in negative x cubed minus 3 times negative x. That's going to give me negative x cubed. And what's negative 3x? Positive 3x. Now let's put a negative in front of this guy, because we want negative f of x. So that means put a negative out in front. And that's going to be negative x cubed plus 3x. Do these match? Yes. So therefore, they do match. So therefore, it is symmetric around the x-axis. Okay? Question. Right, complaint. All right. That's pretty much those problems right there. And of course, that's a circle, and the circle is symmetric around both. That's not a big deal. All right. So, what are the things that are in 4.1? 1. Make sure, as soon as I can pull it up. 1. Make sure you know vertical and horizontal shifts. 2. Make sure you can manipulate a function. Now, what does that mean, manipulate a function? That means when you're given a function, you can find the y-axis, the y-intercept, the x-intercepts, and the vertex. Now, sometimes they're not going to give you the form that gives you these things, and you have to be able to manipulate the function to be able to get those things like we did in that problem. Okay? Make sure you can plug and chug. Make sure you can find the domain. Now remember, the domain is affected when you've got a fraction or a what? A radical. So that function that we saw that had a x or a p in the denominator, that's a fraction, so it's affected. And 5, make sure you can sketch these graphs. Okay, that's 4.1. Now, just to give you a taste of 4.2, so some of y'all can be working on it, this is not a lot of passion. Talking about this one, hold on. Where's this? There. We're talking about composite functions. Well, composite functions It's what you did back in pre-algebra. It was called substitution. Okay? And we'll get into this tomorrow, which means Wednesday. You know how to do all this. You just got to remember to lift your pinky up when you're talking about composition of functions versus in pre-algebra, you added, subtracted, multiplied, and divided, and substituted in functions. So we're going to be doing a little bit of algebra in the next section, okay? Questions?
Yes, sir.
All right, y'all get out of here. Have a good day.
Thank you, you too.